Hey everyone, this is meteorologist Ben Price at the National Weather Service in Springfield, and welcome back to another Weather Unlocked session. This is video 42, and we are going to be continuing our talk about hurricanes. This is part 2, which will be discussing the structure, hazards, and the forecasts and products meteorologists make for hurricanes. If you haven't watched part 1 yet, that video focuses on the formation of hurricanes. So if you want to learn about that, go back and watch that, but it's not required if you want to just watch part 2 right now. So without further ado, let's get started. So now that we've discussed the formation of hurricanes in the first part, let's dive into the anatomy or structure of hurricanes. And of course, the main component of this is the eye. This is a calm and generally clear area of sinking air and light winds. There is still some speculation on the formation of the eye, but the most accepted theory is that the fast-spinning air sends clouds and precipitation outward. Think about it like you're in a car. If you take a sharp turn to the left, you feel like you're getting flung to the right. In a hurricane, the winds are turning really fast counterclockwise, or left, so clouds and precipitation are going to want to spread outward to the right, leaving the eye clear. Additionally, with such low pressure in the eye, air is rapidly rising and leaving the eye out the top. Some of this air is flung into the center and is forced to sink back down. That creates the clear air in the eye. The next major feature is the eye wall. This is the ring of tall thunderstorms around the eye that produce heavy rains and the strongest winds. Again, theory is that because of the fast spinning around the eye, there is an increased convergence and upward motion around the low pressure for vigorous thunderstorm development and strong winds. Then there's the rain bands, which swirl outward from the storm in a spiral fashion. Although, from satellite, these can't be seen well as there's a dense cirrus cloud deck way up high that covers the rain bands. Here you can see the comparison between satellite imagery, showing the clouds, and radar imagery, showing where the rain and thunderstorms are. You can clearly see the eye in both images, as well as the eye wall. But again, the rain bands are only able to be seen swirling out on the radar imagery and can't really be seen in the satellite imagery. Now let's get into more detail on hurricane hazards. But before we talk about all of them, it's important to go over the Saffir-Simpson scale, which determines the category of the hurricane. This scale is determined only by wind speed that is observed by special aircraft that fly into the hurricane and record wind speed along with temperature, pressure, humidity, etc. So, Category 1 has the weakest wind speeds at 74 to 95 miles per hour, and Category 5 hurricanes have the strongest wind speeds at greater than 157 miles per hour. Any hurricane that is classified as a Category 3 or higher is known as a major hurricane. This means that devastating damage will occur regardless of the category rating. And I want to stress that point, because some people will underestimate the impacts of a Category 3 simply because it's not a Category 5. Both categories are capable of devastating damage. Additionally, the wind speeds are those measured over open ocean and are the maximum wind speeds measured. So, many places within the hurricane may not see wind speeds that high, especially when it moves over land, where wind speeds will naturally slow down since land, buildings, and trees introduce more friction to the wind than open water. And lastly, another important point is that even Category 1 hurricanes can still do significant damage. This is because wind speed is not the only hazard that hurricanes bring. So let's talk about those different hazards now. We just talked about wind, but the other main hazards produced by hurricanes include storm surge, tornadoes, freshwater flooding, rip currents, and marine incidents. Now, taking a look at those 6 hazards, which do you think results in the most fatalities? Well, many people would think wind, since the category is based on wind speed, and others would say tornadoes, since tornadoes do create a lot of damage. But the answer is actually freshwater flooding at 57% of hurricane fatalities. This means that the rainfall alone creates a deadly flash flooding threat. The next highest is rip currents at 15%. Then it's wind at 12%. And then it's storm surge at 11%, marine incidents at 3%, and lastly tornadoes at 2%. One thing to note is that these statistics are from after 2013. Before 2013, the deadliest hazard was actually storm surge at 49%. Such a stark difference is the result from identifying storm surge as the deadliest hurricane hazard and then implementing mandatory evacuations from the coast as a response. So if you are ever in an evacuation zone in the path of a hurricane, please heed that warning. Storm surge is one of the deadliest hazards if you are on the coast. and we'll talk about that a bit more in depth soon. So freshwater flooding is the deadliest hazard produced by hurricanes. Part of this is due to less fatalities from other hazards thanks to mandatory evacuations and updated building codes, but another part is that people often underestimate flooding as a hazard. As a recent example, the flooding from Hurricane Helene in western North Carolina was absolutely devastating. Many outlets reported that people were unaware of the risk that the hurricane was to them since they were so far inland. However, the excessive rainfall created conditions for historic flash flooding that sadly took many lives. Rip currents are another tricky hazard, as they generally occur well before a hurricane gets close to land, because, well, who would want to go swimming during a hurricane? But anyways, rip currents are very powerful currents of water moving away from the shore. Wind speed picking up from a hurricane approaching can produce these along the coast. If you are ever caught in a rip current, make sure to stay calm, don't fight it, and swim parallel to the shore and towards a lifeguard if possible. Now, I haven't been trying to downplay wind as a hazard at all. It is certainly a main hazard of hurricanes. It is just important to also be aware and recognize all the other hazards as well. And the wind itself isn't necessarily the hazard, but the damage it causes is. Falling trees or buildings and flying debris can cause significant damage as well as threat to human life. Now we can talk about storm surge, which is basically characterized as a large wall of water that's pushed inland by the strong winds of the hurricane. This wall of water can be several feet high, sometimes into double digits. And sometimes it's hard to grasp exactly how high a 10-foot or greater storm surge is, but that is basically submerging houses. This makes it very deadly for anyone near the coast during a hurricane, so it's important to heed evacuation orders when they are issued. An important caveat to storm surge is that the strongest surge does not necessarily occur at all locations that the hurricane impacts. Because of the counterclockwise flow, the strongest surge will be on the right side of where the storm is moving. This is where the winds push the water up onto the land. Sometimes there's even an anti-surge to the left side of the storm motion, where winds may actually push water away from the shore. This is generally how storm surge works. Now, marine incidents from hurricanes are few and far between, since forecasts now allow to reroute ships away from the path. That being said, though, they still do happen, especially during storm surge, which can toss boats up onto land. Large wave swells out in the ocean within the hurricane can also toss boats, especially smaller ones that are caught in the storm. Lastly, tornadoes do account for some fatalities and damage in hurricanes. These generally occur in the outer rain bands of the hurricanes and are usually weaker than tornadoes seen in normal circumstances. However, tornadoes are never something to scoff at and can still produce significant damage. Tropical cyclone tornadoes mainly occur on the right side of the storm's motion, even more so in the front right quadrant of the storm. So, explaining, lots of science short, when this area moves onto the land, the friction from the land creates wind shear that is favorable for tornado formation. And that is why you see most of them on the east side, or right side of the storm motion, and the front right quadrant of the storm. So, how are hurricane forecasts communicated? Well, the one-stop shop for communicating where hurricanes will go and how strong they will be is with the National Hurricane Center's Cone of Uncertainty. This product has everything. It shows the current location of the storm with the X, right here, and yellow shading for the extent of sustained winds that are 39 to 73 miles per hour, this yellow shading here, or that's tropical storm force, and then brown shading for the extent and location of hurricane force winds, which are greater than 74 miles per hour. So this brown-orange shading is the extent of hurricane force winds. It shows where there are current tropical storm and hurricane watches and warnings along the coastlines. So this red line here is a hurricane warning, the blue line are tropical storm warnings, and then hurricane watch is this pink shading out here, and then tropical storm watch is this yellow shading. And it shows approximately where the storm could be and how strong it could be at a given time with these black dots in steps. So, for example, this black dot here says 7 a.m. Saturday, so the storm may be around this area at 7 a.m. Saturday. The S stands for tropical storm, H here stands for hurricane. If there's an M on this graphic, that would indicate a major hurricane, and then the D here is for tropical depression. Then, this white shaded area, which is called the cone, this depicts where the center of the storm could be at those given times. Now this is important. This is where the center could be. Obviously the center is not where all the impacts will be. Winds, rain, and storm surge can still occur outside of this cone area, especially if the center moves along the fringes or the edges of the cone. Then you could have impacts that expand outside of the cone. And also, the cone has statistical data built into it as well, such that the center will stay within the cone 2/3 of the time. This means 1/3 of the time the center will actually deviate out of this forecast cone. So there's kind of a lot of caveats to understand with this forecast. There's some other graphics that are created to add context to those. For example, the graphic on the left here shows the probability of a location experiencing tropical storm force winds at a specific time. So anywhere in this purple area is going to experience tropical storm force winds, basically has a 90 to 100% chance of experiencing those. And then these black lines show, the approximate arrival time of those winds. So as an example, choosing just a point here, if we look at the edge of Massachusetts here, this cape, this has a 40 to 50% chance of seeing tropical storm force winds sometime between 8 a.m. Tuesday and 8 p.m. Tuesday. So probably sometime midday Tuesday, there's a 40 to 50% chance of seeing tropical storm force winds. And then the graphic on the right here shows the expected peak storm surge height at various locations along the coast. So for example, anywhere between the Anclote River and Englewood could see 10 to 15 feet of storm surge in this forecast. These graphics can all be used to understand the location and severity of each of the impacts discussed before. Well, that's all for this session of Weather Unlocked. Thank you for listening, and I hope you were able to learn something today about hurricanes. Make sure to follow us on socials for any weather information, and stay tuned for the next session. Bye now.